Hi guys, welcome to my channel Coding Shinobi. Let's discuss a famous Java interview question related to hash maps. Count the frequencies of all the elements in an array. You are given this array ARR. You have to count frequency of each and every element. For instance, 1 occurs for 3 times. 1, 2, 3. So count of 1 is 3. 3 occurs for 1, 2, 3 times. That's why count of 3 is 3. Similarly, for 5, it's 2. For 2, it's 1. And for 8, it's 1. Let's try to solve this using a basic approach. Now, when you are reading the array, you are solving it in your head like we were taking 1 and then scanning this total, the remaining array, and then counting the number of ones that are occurring in the remaining part of the array, right? Similarly, we are going to do it in the code as well. Like we will take one for loop to take one array element and another for loop to traverse the remaining part of the array, to scan the remaining part of the array and maintaining the count of the particular element. I'll take this one and then scan using this array j is equal to I plus 1. That is from 1, I'll scan this total array and whenever I find this element, I'll just increment the count. What is the problem with this code? We are not eliminating the duplicates. As a human brain, you know that one has been already counted and then you have processed it in the head, right? Similarly, the code should also know if the one is repeated or not. For that, we can maintain another array of the same size, which will tell us that whether this element is already visited or not. What we will do that we can take one visited array. Similar size, suppose n is the number of elements in array. Whenever we encounter these duplicates, what we can do is we can mark it with a specific number. For example, let's consider your input is going to be positive. Your all numbers are positive, then we can take this visited of I, or we can update the value of this visited of I to -1. To know that this element has been already visited, don't process it again. This we will maintain this flag visited of I is equal to -1. Let's see how the code will look like again. And let's try run on this code now. Now I have introduced this visited array, which is of same size of our original array. Now I'm using this outer for loop to take one element and inner for loop to process the element and get the count of that element. Okay. I'm extracting this element ARR of I into element variable. Initially, the count will be 1. Also, in the previous code, I made a mistake that took the count as 0. So I fixed it and made the count as 1 because we are processing this element and it is already present and we are considering it. So initially, the count will be 1 because we're not considering this element in this loop, right? So we have to take the count as 1. Again, if my element is already visited, then I won't process it. I'll just increment the value of I and then I'll go ahead and process the next element. Let's try it, guys, so that you have better idea. Initially, my visited array has all the values as 0. First element, my I is equal to 0 and my element is 1, and initially my count is 1. My visited of I, which is this element, which is 0. So we will continue process this element for int j is equal to I plus 1. From this element, we'll start to see what is the count of 1 in this remaining array. If my element is not visited, if it is not equal to -1, it is the element is equal to ARR of j, which is this one, which is this one. 3 is not equal to 1. Then we'll increment the j. Now my j becomes 2. Earlier it was 1. Now ARR of j is 1. And my visited of 2 is 0. That means it will go inside this for loop and it will increment the count. The count was 1. Now I'll increment it to 2. And I'll set this visited of j, in our case it's 2, to -1. I'll again increment the j. Now my j becomes 3. Is ARR of j 5 equal to element that is 1? No. I'll increment the j. My j becomes 4. Is ARR of j is equal to the element? Yes, it is. Then I'll increment the count. Mark the visited of 4. is equal to -1. Again, my increment, my j will become 5. Is 3 equal to 1? No. Is 2 equal to 1? 3 equal to 1? No. So we have found all the occurrences and exited this for loop. Now, since we have already eliminated the possibility that visited of I will be equal to -1 because we are not considering that those elements who we have already visited. So this visited array will act as the storage for the count of particular element as well. So I will just update the visited of I to the count, and in our case, count was 3. Now we'll proceed to the next element. I is equal to 1. For 3, we'll start from I is equal to 2. My j is 2 in this case. My ARR of j is 1. My visited of j, which is visited of 2, is equal to -1. And also my element is not equal, so I'll skip this element. I'll go to next element, which is 3. 3 is 5. 5 is equal to 3. No. I'll skip this element. I'll go to the next element. 4. Is my 4 equal to? No. Go to the next element. 3 is equal to 5. Now 3 is equal to 5. And also my visited of j is not equal to -1. So I'll increment the count. The count we had set it to 1 here, guys. Our element is 3. Our count is 1. I'll update the count. Now I have set the visited of j, which was equal to 5, to -1, which means we have already processed the 3. Similarly, count for 3 will be 3 after iterating through the remaining array. Now, suppose we have processed 3 and we move on to the next element, that is 2. I is equal to 2. Now my element is now my element is 1. But visited of I is 2. Visited of 2 is -1. So we won't even go below and process the element again. We will just return the control from here to the for loop again, and we will start processing the other elements now. Don't worry, we are going to code this, so you will be seeing it live. We will code it and we will run the program. Don't worry. Let's analyze the time complexity. As you can see, we are using this outer loop and it has exactly n iterations. And for n iterations, we are approximately traveling n times. So n into n becomes n square. So our time complexity is n square. And what is the space? We are using this visited array, extra space of size n. That's why our space is n. Also, if we'll consider this for loop for printing of the count of the elements, it also takes n time. But since the greater factor is n square, our time complexity is n square and space complexity is big O of n.
So guys, I have written the code for the approach that we discussed right now. N is the length of array. I have taken this visited array. Let's run this program and let's see what is the output of this program. Now if you'll see, my count of 1 is 3. My count of 3 is 3. My count of 5 is 2. My count of 2 is 1 and count of 8 is 1. I'll increment the count of 1 and then 5. Let's run this program again. Now my count of 1 is 4, count of 3 is 2, count of 5 is 3, and count of 2 is 1. So this is how you code the naive or basic brute force approach.
Now the time complexity of this algorithm is n square. Can we reduce this time complexity to n? The time complexity can be reduced to n using hash maps. Since we are using hash maps, so space complexity cannot be reduced, but we can definitely reduce the time complexity using hash maps, and let's see how we can do that. Okay, guys, this is our array, and let's see, I have this hash map. Initially, my hash map is empty. Now I'm scanning this array and using a for loop to scan this array. Okay, I'll iterate the array from 0. First, my element is 1. I'll put this value into my hash map, like count of 1 is 1. I'll go to next element. I'll see if 3 is in my hash map or not. No, I'll update the count to 1. Now I went to the second index, that is 1. I'll see in my hash map if there is 1 present in my hash map or not. Yes, I can see there is a 1 present in my hash map. So I'll update the count. Now my I increments, I comes here. 5. 5 is there hash map or not? No, so I'll add 5 in my hash map. I'll increment my I by 1. I'll see if 1 is there in my hash map. If there is, so I'll update the count of 1 in my hash map, which becomes 3. I'll increment my I. There are 3 present in my hash map. Yes, there is. I'll update the count of 3 to 2. I'll go here. I'll see if I have 2 already present in my hash map. There is no 2 present, so I'll add 1 in my hash map. I'll increment I again. So now 3. 3 is present in hash map, so I'll update the count of 3. 5 is present in, I'll update the count of 5. And lastly, I'll insert 8 in. Guys, let's see how the code of this solution would look like. I have declared one hash map named as HM. For every element, what I'm doing is like extracting this element into element variable. Initially, my count is 0. If hash map contains the element, then I will just update my count variable and get the count that it has currently. I'll just put this element into my array and I'll increment the count by 1. So if my array is like this, and this is my hash map, my I will be 0, my element will be 1, and my initial count is 0. If my hash map contains key of element, no, it does not. So what it will do, the control will come here. I'll put element into the hash map and increment the count by 1. My I will become 1. My element is 1. The count is 0 again. Does my hash map contains this element? Yes, it does. Then I'll get the current count. So my count becomes 1. And when it exits this if condition, it will again put the element. And in hash maps, do you know that, right? Like duplicate keys are not allowed. When you try to insert a duplicate key, it will just update the value of that particular key. And then we print it. Our hash maps have counts of every element. I'll loop through, I'm extracting all the keys from the hash map, iterating towards that key, and then I'm just printing it using the print statement. So what is my time complexity for this? Since I'm iterating or visiting the every element once, so my time complexity is n because of this for loop. And also printing takes another n time complexity. So n plus n becomes 2n, which is approximately equal to n. We are using hash map. The worst space complexity is big of n again, because if there are unique elements like 1, 2, 3, 4, then hash map will contain all the unique mappings of all the unique elements and the frequencies will be 1, of course. So worst time space complexity is big of n. I hope you guys loved the video. I hope you learned something. I hope you liked liked how we covered the topics, going from brute force approach to the optimized approach. If you have any questions,
Now, guys, let's look at the hash map approach. I have this array defined declared here. N is the length of the array. Then I have declared one map, which is hash map, and the key is element and value is count of element. Let's see. Let's run this program now. Now I can see count of 1 is 3, count of 2 is 1, count of 3 is 3, count of 5 is 2, and count of 8 is 1. Let's change the values again. Let's increment the count of 1. Run the program again. Then you can see count of 1 is 4, then 2 is 1, 3 is 2, and count of 5 is 3. And you guys might be aware, right? Insertion in hashmap is of constant type. Also, getting an element in an hashmap is of constant type. And also, if it contains the key in your hashmap or not, if you want to know that information as well, then it is of constant type as well.
feel free to ask about it in comment sections. I would be more than happy to solve your queries. And all the best for your interviews, guys. Ace your interviews. Thanks again for watching the video. If you like the video, make sure you hit the subscribe button. Thank you, guys. See you again in the next video.